Hi everyone, welcome to our channel Learn Competitive Programming with CodeChef. If you are interested in competitive programming and want to learn and master data structures and algorithms, then this is a one-stop destination for you. Every week we'll post CodeChef problem explanations, conceptual videos on various programming paradigms, and also conduct live problem-solving sessions. But before we actually get started, here's a reminder to hit the subscribe button if you haven't yet already. Great, now that you have subscribed, let's get started. Today we'll be solving the problem Unpleasant Ones, which is a simple problem and belongs to the June lunchtime. So let us go to the problem statement. The problem statement here says that the ugliness of a string is defined as the count of two consecutive ones present in a given string. So this is talking about a string which has ones and zeros in it. It means a binary string. So a binary string's ugliness is the count of two consecutive ones present in it. For example, if you see this string, this is the first pair of consecutive ones present and this is the second pair of consecutive ones present. Hence, the ugliness of this string is 2. Now, the question is that we'll be given an array of integers. So, we'll be given normal integers like 3, 2, 8 and so on. So, this is what will be given, and we have to find any ordering of the array. Now, what does any ordering means? So, 3 to 8 is one ordering of the array. Some other ordering can be 2, 3, 8 or 8, 3, 2. So, these are the various ordering of the array that can be there. Now, we have to find any ordering of the array such that the ugliness of the concatenated string of binary representation of these integers is minimum. So, if we convert these strings into their binary equivalents without any leading zeros. So, mind this that we don't have to keep any leading zeros. Means 3 will be written as 1, 1 in binary. Even though we can write 0, 0 here, but there is no need. So, this will not be there. It will be 1, 1. 2 will be written as 1, 0. 8 will be written as 1, 0, 0, 0. So, this is how we'll write it. There will be no leading zeros. So, when we have written the binary equivalents of all these integers, then we are supposed to concatenate them together in such a way that the ugliness of the this concatenated string should be minimum. Now, how can we minimize the ugliness? For that, let us take an example here. So, this is an example in which we have taken 6 integers 3, 2, 13, 6, 4, 9. And these are the binary representations of these particular integers. Now, we have to find an ordering such that the ugliness is minimum. Now, one thing for sure will be that for every individual integer, the ugliness can never change. It will remain the same no matter what the ordering of the array. Why is that? Because for any individual integer binary equivalent representation, we cannot change the ones and zeros that are there. So, we can maybe change 2, 3 or we can change 6, 13. So, instead of 13, 6, we can write 6, 13. This is correct and this is also correct. But for every individual, like for 13, the binary equivalent is 1, 1, 0, 1. So, we cannot change it to 1, 0, 1, 1 or something. So, this is wrong. We cannot do this. It means that this is going to remain constant and the ugliness of this particular number is going to remain constant. Now the question is that when we combine these integers, means we concatenate the binary equivalent of these integers, then what will be the change in the ugliness? What will be the increase in the ugliness, and how can we minimize that increase? So right now, the ugliness of all these individual integers are, the ugliness here is 1, here it is 0, here it is 1. In integer 6 it is 1, 0 and 0. So the ugliness right now is 3 of this entire of the individual, if we see the ugliness of these individual integers. Now, how do we combine them? So for combining them, we have to develop a strategy. We cannot just combine them in any manner we want. So the strategy that we are looking for is that at the end of this one, instead of another one, there should be a 0 present. Only then we will be able to minimize our ugliness, because if there is 1 1 when we are combining two integers together, then definitely it will create an increase in the ugliness. But suppose that if it is 0 1, then it will never increase our ugliness will remain the same. So we have to see the property of the binary equivalence of integers. The finest property that we can use here is that for every even number, the last bit of the even number is 0. As you can see, for 2 the last bit is 0, for 6 the last bit is 0, for 4 the last bit is 0, and for every odd number the last bit is 1. So you can see for 3 the last bit is 1, for 13 again the last bit is 1. Now consider these four probable conditions, that we can place either even number together, or we can place even odd, or odd even, or odd number together. In all of these situations, which will minimize our ugliness? Definitely, if we place an even number alongside an even number, then it will definitely minimize our ugliness. How? Because at the end of one even number, say we take 6, at the end of this 6, the last bit is 0. Now when there is another even number, then now it doesn't matter, right? Because every number that we are using here, we have already established that there will be no leading zeros. So here it will be 1. Now 0 and 1. So there is no rise in the ugliness. The existing ugliness will remain, but there will be no increase in the ugliness. Now again, if we have one more even number, then we can place that even number as well here. So whatever is there in this the second even number, whatever the binary equivalent may be, but the last bit will be 0. Now again, any number that we place here will start with 1, because it can never start with a leading 0. Again, the ugliness will not increase. Now when we are finished, when we are done with all the even numbers, then we can start with an odd number. Now when we start with an odd number, even then, now when we are starting with the odd number, so even then, just before the odd number, there we have placed an even number, right? So the last bit was 0, and the odd number, or for that matter any other number, will start with 1, right? So again, there will be no increase in the ugliness. And now when you have placed all the even numbers beforehand, and after that you are placing all the odd numbers, so then you will have no choice but to just keep placing them, because there will have to be some rise in the ugliness if there are all the odd numbers left now, because the odd numbers end bit is always 1. So that is how this problem is going to be solved. So a probable solution to this problem will be that we segregate all the even numbers first and place them together, and after that we segregate all the odd numbers and place them together. So this is one probable ordering that will give us the minimum ugliness of the array. And this is not just one answer that is completely acceptable. There can be many other orderings which are acceptable, or there can be many other ways of doing this question. So definitely you can think about a solution and post it in the comment section, so that we can discuss about it and others can also think of new methods of doing it. Now, this is just one problem that you have solved. So there can be many other problems that you get stuck at. So for enhancing your competitive coding, you can definitely go on the Unacademy platform, where CodeChef conducts free live classes related to competitive programming. And if you find the content useful there, you can also take the Plus subscription, which will help you, get one step closer to your goal of competitive programming. Talking about the input, output and constraints, the first line of input will be the number of test cases, and then we need how many integers we'll have. That will be represented by an integer n, and then in the second line we'll have the integers that we need for our question. Now for output, we are supposed to print that ordering that we have found out. So any ordering of the array which has minimum ugliness. So that ordering of the array we are supposed to print. And if there are multiple answers, then we can print any one, so all of them will be acceptable. The constraints are not too large, so n will be only up to the range of 1000, and each individual integer that can be given to us is up to 10 to the power 9. So don't get scared by this 10 to the power 9, because we are not performing any operation on any particular individual integer. We just have to check whether it is an even number or an odd number. And for doing that, we'll just take the time complexity of order of n. So this problem can be solved in time complexity order of n, and n can be maximum 1000. So guys, let us see the code now. But I would hope that you'll try to do this problem or this code on your own, because it is very simple. But if you are stuck, then definitely check out the later part of the video. So guys, we'll be discussing the code in C++. First we'll take the input for number of test cases, and then we have our main logic in this function known as solve. So first we are taking inputs. So we are taking input for the number of integers that are there. Then this int x that you see here, this x will represent every integer for which we are taking input. So the array of integers that we have. So we'll run a loop from 0 to n so that we can take input for n integers. So now every time we are taking input for an integer, we will store that in x, and just after taking the input, we will check whether it is even or it is odd. So if it is even, then we will store it in a vector which we have named even, and if it is odd, then we will store it in a vector named odd. So we have segregated the even numbers and the odd numbers in separate vectors, or you can also use an array if you want, so that is not a problem. So we have separated them. Now what we are just supposed to do, first we will print all the even numbers, and then we will go ahead and print all the odd numbers. Now one thing to keep in mind is that if you print all the odd numbers first and afterwards the even number, then also your answer could be wrong. Because if you see here, then if we place 6 after 5, then we are increasing the ugliness. Because at the end of 5, the last bit is 1. And the starting bit of 6 will definitely be 1. So we are increasing the ugliness here if we are placing an even number after an odd number. But if we are placing an odd number after an even number, that is 6 after 5, then we are not increasing the ugliness, because 6 end bit is 0 and the starting bit of 5 is 1. So we are not increasing the ugliness here. So the right approach will be to first print all the even numbers and then print all the odd numbers. That will be one of the correct orderings, such that we can minimize the ugliness of the array. And then you can see that I have used \n, which is an escape sequence, so that for the next test case, the answer would be printed on a separate line. So that's it guys, this was the code. If you've understood the problem, then please do like the video, and if you have any doubts, then please post them in the comment section and I'll be happy to help you.